So for the triangles, in our whole last unit, we were just doing right triangles. And in this whole unit, we're just doing right triangles. Okay? So let's see if you can remember all the things we've learned to do so far. So in a right triangle, if you know two sides, how do you find the third one? Oh, you can use your Pythagorean theorem. So the Pythagorean theorem, that's going to be your a squared plus b squared equals c squared stuff. And that works for any two sides, right? If you know the hypotenuse in a leg, you could find the other leg. If you know two legs, you can find the hypotenuse. And all is well with the world. Do you have to even know the angles at all to find the side length with this guy? All you need to know is that it's right. Okay? Well, what if you only know one side and one of the acute angles?
30, 60, 90.
Okay? Yeah, that's what we did last unit, where you say you're going to check to see if you have a special has a P in it, special right triangle, which is your 30, 60, 90, or your 45, 45?
Yep.
Okay, so you've got those. Good, we remembered junk. What if it's not a special right triangle? How are we going to find the missing side? Well, see, this is what you learned last class. What magical new tool did we get last class? We got trigonometry. For trigonometry, all you need is one of the acute angles and one of the sides, and you can set up either your sine or your cosine or your tangent to find the other sides. And that's what your whole homework was doing all that garbage. You're like, yeah. Now, do you want to go to all the trouble of setting up a trig problem if you don't need to? No. So I recommend, if you're having to find sides, check to see if you can do one of these guys first. And then if you're stuck, use trig. But what about the angles? How do we find them if we're missing them? What if all we have is a right angle and a side?
Use the inverse. You somehow use it.
You have to undo things. Now I want you to think back to the Dark Ages for a minute. If I had an x, oh, that didn't write. Let's get something that writes. If I had an x and I added 3 to it and got 5, how can I get back to just having x by itself?
You subtract 3.
How do you know to subtract 3?
Because that's going to isolate x.
Well, why does it isolate x?
Because the x is itself. You're making it 0.
Because this is a plus 3, and what's the inverse of plusing 3? Minusing 3. So you would do that, and x would be all by itself. And then you got a little bit older, and then you learned about, okay, well, what if I had x times by 3 and got 27? Could I still work backwards to figure out what x is?
Yeah, good.
How would you do it? And how do you know to divide by 3?
Because it's the inverse.
Because it's the inverse of this multiplied by 3. The opposite of multiplying is dividing. And x ends up being 9. Okay? What if I had the square root of x equaled 11? And I wanted to get just x. Yeah, what's the opposite of the square root? Squaring it. And the root and that would cancel out, and I'd have x is 121. Because of course you memorized that one for the last test, right?
Yeah.
Of course you did, yeah. Okay? So then, what if I wanted to find the sine of an angle? Do y'all remember how to get the sine of an angle? What's our ratio going to be for sine?
Opposite over hypotenuse.
It's opposite over hypotenuse. That's your SOHCAHTOA reminder? Yeah, okay. Well, what if I just want the angle? What if I want to go back and figure out what angle gave me this opposite over hypotenuse? How can I get the sine off of theta? Now, is sine being times by theta? Is this sine times theta gives me this? No. This is an operation. I am signing my angle to get this fraction. How do I unsign? I have to think, what's the opposite of signing?
Unsigned.
Well, we think it would be called unsigning.
Negative sign.
It's not negative sign. Negative is the opposite of adding.
Cosine.
Cosine.
No, cosine is a different trig function.
NIS instead of
Something.
Okay? So what we do, it's very exciting. The inverse of signing is the inverse sine.
Never heard of that before.
I know. So it's called the inverse sine. So the inverse sine. And the way you write the symbol for inverse sine is going to look kind of doofusy to you. Just play with me, okay? It's the sine with a -1 exponent. And guess how you say this symbol? You say inverse sine. You don't say sine to the -1. You say inverse sine. Okay? That's what that is. And if you look on your calculator, what's right above your sine button?
Inverse sine.
Inverse sine. Now, what this does is this undoes the sine function. So, oh look, I have signed theta here. How do I get back to just theta?
Inverse sign.
I need to unsign it, so I need to inverse sine what was done. But if you do it to the left, you have to come over here and do it to the right. And it always goes in front, because you have to sine a thing, or inverse sine a thing. So I'm going to inverse sine both sides. Like, okay, written. And you always write this stuff down, right? Because you want to show your work and not mess up?
Yeah.
Smile and nod. And so if I inverse sine sine, those will cancel out. And look what's going to be left all by himself.
Theta.
Theta. And theta equals whatever you get when you do the inverse sine of the opposite over hypotenuse. That's your exact answer. There it is. That's how you get theta. Now, this is probably going to be kind of difficult to tell how many degrees that is. Who do you ask to find out how many degrees you get from the inverse sine of this?
Calculator.
Ask your calculator, your new best friend. So,
Hello.
do you know how to type it in?
Nah.
So if you want to type it in, did you check to make sure you were in degree mode still?
I am not.
Make sure you're still in degree mode. Okay, mine is still in degree mode. Okay? So if you want to inverse sine something, you're going to press the second button and then the sine button, and it'll let you inverse sine whatever you want. Now, I don't have a particular number here, so let's try one. Oh, wait, before we do that, do you mind if I ask you to guess? I will give candy to who guesses right. What do you think the inverse of the cosine
Inverse.
is? What do you think?
Inverse of the cosine.
And how do you think I write inverse cosine?
You write sine cos with the negative to the -1.
Cos with the -1 on it. That's your inverse cosine.
Thank you.
And so theta is going to be the inverse cosine
Get a piece of candy.
of adjacent over hypotenuse. That's what you would get if you did all this work again. And what about the inverse operation from tangent? How do I untangent stuff, do you think, Elliot?
Tan,
Mm-hmm.
and then the -1,
And how do you say that?
inverse tan.
Inverse tangent. Woo! And so the inverse tangent, when you inverse tangent your fraction, which will be adjacent, opposite over adjacent, right?
Yes.
Yeah, did you go get your stuff? You got it right. Yeah, get your stuff.
Yes! What'd you know?
So you've got these. The main thing you need to remember is to undo a trig function, do the inverse trig. There, that's your whole lesson.
Oh, wow.
Now, would you like to practice a couple just to make sure you aren't doing it wrong?
Yeah.
Okay, so let's try this one. Okay, let's figure out how you would set it up and how you would solve it. So it says find the measure of angle A. Okay, find angle A. Did you find it?
Yeah.
There it is. Okay. What is something I could set up that would help me find angle A?
The opposite.
Well, I have the opposite side. What other one do I have?
Hypotenuse.
Hypotenuse.
Really? Do I have my hypotenuse?
Yeah, no.
I don't know how long my hypotenuse is. Could I solve and find the hypotenuse?
Yes, you could.
Yes, but do I want to do extra work?
No.
Absolutely.
No, I'm lazy. So what if I just use this adjacent guy I already had?
I know that tan.
And so that would be tangent of my angle is going to be my opposite over my adjacent. I don't know what my angle is though. Oh dear, if I could only get the tangent off my angle, how can I untangent angle A to figure out what got me this ratio?
The inverse tangent.
I could inverse tangent, but if I do it to the left, you got to do it to the right. And those cancel out, and A equals whatever the inverse tangent of 15/20ths is. And I bet your new best friend, the calculator, could tell you that if you type it in.
Really?
So could somebody please type in the inverse tangent of 15/20ths, and this problem wants it rounded to the nearest whole degree. So A is going to be approximately equal to
37.
37?
37.
E. That's it.
Did you put the degrees?
Oh, we should put the degrees. We do not want to leave it naked. Very good. Go get it. Get more. So try setting up the next one. It doesn't take long. Take the time to write them down. I know a lot of you are not going to like writing stuff down in this unit. Too bad, write it down anyway. So you look at that, and I want angle X. So I've got opposite side and the hypotenuse. Which trig function is that?
Sine.
Oh my gosh.
I'm so...
No, what?
No, I got confused.
Okay. Well, welcome to my world. I do that all the time. Okay? So I'm probably going to sine something. It's going to be X. I don't know how big X is, but I know that its sine is 23 over 47.
Yep.
But I don't want the sine of X. I want just plain X. Presley, how the heck am I going to get that sine off of my X? Are they being multiplied?
Yes.
No, this does not say, no, look, it does not say sine times X. It says sine X. That's a thing you do. What is the opposite of sining?
Inverse sign?
So I'm going to inverse sine to get rid of sine. Okay? But if I do it to the left, I have to do it to the right. The inverse sign will take off that sign, and we'll end up with whatever X is, and it wants you to find it to the nearest degree, so you're going to be doing approximately equals now. And what does your calculator say the inverse sign of 23/47 was?
It says about 30.
About 30?
No, about
29? Is it 29 or 30?
29.29.
29.29, which rounds to 29, not 30. Practice those rounding skills. It's been a long time since third grade, but I know you can do it. Yes?
I have a question about the one.
Yeah, shh. Question?
Do you
Yes.
not simplify the fraction?
You don't have to simplify it till you're getting to the answer. If you want to simplify it here, you could simplify that to 3/4. Guess what happens when I inverse tangent 3/4? I'm going to get the exact same thing. Okay? So you don't have to simplify till you get to the end, but if you want to do it sooner to make yourself feel better, you do it. Okay. Now, here's where it starts getting fun. You're going to learn how to solve a right triangle. I didn't know a triangle was something you could solve. How do you solve a right triangle?
Oh, no.
Well, read the words on your paper.
How? Here?
You know all the
Oh, all this.
That means find all the sides and
The angles.
find all the angles. So you always know one of them. Guess which angle you always know in a right triangle?
The right angle.
Oh, wow, that's great. So you always know this one. So in this first guy, I have the 90 and the 48. Oh dear, do I have to do trig to find that third angle?
No.
No, how many degrees are in a triangle?
180.
So just do your subtraction and tell me, how big is angle A?
42 degrees.
42 degrees. All right. Now, here's the fun part. Now you have choices. Which side do you want to find, X or Y?
Why?
I heard X first, so we're going with X. Now, watch this. If I'm going to do X, what's one of the trig functions I can set up to find X?
Do 42.
Oh,
42.
wait, which angle should I use?
42.
Do I have to use the 42?
You know?
Could I use the 48?
Yeah, man. Your desires.
Yeah, you get to pick. So if I chose to do the 48, what's a trig function I could set up with the 48?
10.
See, I'd be setting up opposite and adjacent.
You could do 10.
So I could do the tangent of 48
Opinion, please.
would be 70 over X.
Sure thing.
But what if I didn't like that 48-degree angle? It talked bad about my brother. Could I use the 42-degree angle to find X?
Your desires, so.
Well, if I did that, which trig function would I be setting up? This would be opposite over adjacent, so it would still be the tangent, but guess which one's on top now? The X would be on top, and the 70 would be on bottom. It depends on which angle you're referencing. Now, shouldn't this side be the same length no matter what?
That's actually.
Yeah, it actually should. So how would I solve this red version?
You times X.
I'd have to get X off the bottom, so I'd have X times the tangent of 48 equals 70. And then how would I get X from there?
Tan 40.
Divided by 10.
I have to divide off the tangent on both sides. And what does X end up equaling onto the nearest whole number?
70 divided by 10.
I'd say 63.
70 divided by tangent of 48
Yes. Yep.
is how big?
63.
63?
Yeah.
Okay, now let's do the purple version, where we focused on the 42-degree angle. How would I get this X by itself?
You do times 70.
Times
I would multiply to get the 70 off the bottom, and X would be whatever 70 times the tangent of 42 is. So somebody ask your best friend, what is 70 times the
Actually,
tangent of 42?
Not 42, it's 48.
No, I did the 48 before in the red guy. Now I'm using the 42-degree angle. I chose to use it.
63.
See, I chose a different one, so when I did the tangent of 42, X ends up being the opposite, and 70 ends up being the adjacent. See, I picked a different reference angle. Aha! But what does X still end up being? Still ends up being 63? Yes, and it should be approximate because we have rounded it to the nearest whole thing. Okay? So the nice thing here is if you have more than one of the sides, or more than one of the angles, you get to pick which one you want to use. Sine, cosine, or tangent. Just pick one that you know how to set up.
Wait, that doesn't use the opposite though.
Which one doesn't use the opposite?
The one we just did.
The tangent?
Isn't that what we did last class?
Oh, we did. You mean we did it inverse?
Yeah.
Oh, is it okay that some problems don't require the inverse? Yeah, that's totally okay. Okay? Because I could find those angles just by subtracting from 180. Oh, darn. Let's do one that requires it then. Here we go.
That part of the script.
So look at the last one. We're going to skip this guy over here. We're going to just do the last one. Okay? What do you think you should find first? Okay, I've got this angle's 90. I don't know the other two. What's something I can find? Could I find this side using what? I've got two sides of a right triangle. What formula can I use?
30, 69.
No, oh, do I know it's 30, 60, 90?
No.
Do I know it's 45, 45?
No, you can use control.
No, so I can't use a special, but I can always use Pythagorean theorem if I know two of the sides. 8 squared plus z squared equals 17 squared. And of course, you memorized your special Pythagorean triples, right?
15.
But, or you could do the work, and z ends up equaling 15 if you memorized your triples. See, us lazy people who use these a bunch, we memorize them so we don't have to do as much work.
Like this, do it.
I know. So z is 15 now. So now you get to choose. Once we know one of these acute angles, will it be pretty straightforward to find the other one?
Yeah.
Yeah. So we just need to pick, do I want to solve for A or solve for C?
C.
C, somebody said C first, so we're doing C. Now, there are a bunch of different functions I could set up to find C. What's one of the ratios I could use to find C?
Well, I mean, any of them.
Okay, so pick one. Cosine.
Yeah.
If I did the cosine of C, what fraction would I set up?
You probably do
For SOHCAHTOA,
15.
I'd need adjacent over hypotenuse,
15 over 7.
so 15 over 17. But maybe I don't like cosine. Maybe I like tangent better.
Yeah.
So if I did tangent, what ratio could I set up using angle C? Opposite over adjacent, so it'd be 8 over 15. But what if I'm just a bit old sinner and I want to sine C? What ratio would you set up? Opposite over hypotenuse. So you've got three different things here you could choose from to solve this problem. So everybody pick one. You picked one you like? Okay, keep it in your head. How would I get C by itself in the cosine problem? How do I get the cosine off of C? Is it being multiplied? It's being cosigned, and the inverse of cosine is inverse cosine. But what if I've been doing the tangent function? If I've tangented C, how do I get C by itself? You can inverse tangent it and do that on both sides. But what if you chose the sine one? How are you going to solve the sine by C?
Inverse sine.
You're going to use the inverse sine. Now everybody who picked one, look, this will cancel. C is going to equal whatever you get here. So my cosine people, put that one in. For my tangent guy, C is going to equal whatever you got when you inverse tangent that guy. So my tangent people, find your C. My sine people, they cancel out. And C is going to equal whatever you get when you inverse sine that fraction. So my sine people do that one. And write down what you got, round it to the nearest whole number, so we're going to be getting an approximate answer. Okay. And so my sine people, when you inversed sine, what did you get for angle C? Okay, now somebody's got to do the sine one.
I think I'll do 28.
Inverse sine of 8/17? You get 28?
28.
Okay, somebody who did the tangent one, when you inverse tangented the 8/15, what did you get?
28.
And my cosine people, when you inverse cosine 5/17, what do you get?
28.
So does it matter which way you do it? No. As long as you pick a relationship that's valid, you can work it any way you want.
It's not valid.
Okay?